Hello. Today I'm going to talk about or continue on the video lesson with balancing equations. In the last video lesson, I kind of gave you the background of why we balance equations. The point is, we're looking for the number of atoms to be the same on both sides of the reaction, on the reactant side and our product side. Okay, so in this video, I'm just going to go right into just doing some general balancing of equations. So I have a couple here for you. Alright, so if you want to, you can stop the video if you'd like and pause it and try to balance this on your own if you feel like you got a pretty good idea on how to balance. Okay. If not, watch the first one and then you can pause it for the second one and try to balance that one and then watch the video and kind of see if you're doing okay. So here's the strategy I do. What I'll do is I'll cut this reaction in half so I have my reactants and my products separated. Then what I'm going to do is I'm going to list the elements. So carbon, hydrogen, and oxygen. Okay, so those are the three elements that I have. Now again, with a chemical reaction, we are not changing the atoms. We are keeping the atoms the same. What we're doing is rearranging them and breaking bonds and reforming bonds. And that's what I was showing you with that water in that last reaction. So what I'm trying to say here is if you have carbon here, you better have carbon on the other side. Okay, you can't lose hydrogen, you can't lose carbon, you can't lose oxygen, and you can't create atoms. There's no atoms being created in a chemical reaction. They're just changing their positions. Okay, they're changing their bonds that hold them together. Okay. All right, so I'm going to add up the number of carbons I have on this side. I have 2. Okay, from here I have 5 hydrogens and another one over here, so I have a total of 6 hydrogens in this compound. Now oxygen is separated into 2 substances, so I have 2 oxygens here and another one for a total of 3 oxygens. On my product side I have 1 carbon and I have 2 hydrogens and I have 3 oxygens. Okay, so now what I'm going to do is I'm going to start using coefficients, and this is the only thing you can do now is use coefficients to balance. You cannot change the subscripts on the formulas because you can't change. We know that carbon dioxide is created. We cannot change that. We can't lose that. So all I can do is put numbers here, and as I put a number here, that tells me how many of these compounds I have. So if I throw a 2 here, that means I have 2 of these molecules. So therefore I have 4 in the 12 and 2 oxygens. All right. So I'm going to start with carbon. Notice hydrogen and oxygen are everywhere. One rule I would recommend you follow is to leave hydrogen and oxygen for the end. Okay. Alright, so I'm going to balance my carbon first. To balance the carbon, I need to get 2 on both sides. So I'm going to throw a 2 right here to balance that. So what that means is that I have 2 of these carbon dioxides. Okay, that's what that means. So total, you don't have to do this every time, but I just want you to get an idea what the 2 means. It means that I have 2 of these CO2s. So therefore, I now have 2 carbons, and now I have to change my oxygens. And this happens all the time. Don't be freaked out because these are balanced and now you're going to disturb it. It's okay. It happens. So I distribute the 2. That means I have 4 oxygens plus 1. That gives me a total of 5. Okay. Make sure when you put a number here that you change all the elements that are going to be affected by that coefficient. Alright, so now my carbon is balanced, so now I can balance the hydrogens or I can balance the oxygens. Now, the little tip here, second tip. Notice that the oxygen's by itself here, right? If I were to balance my oxygens, okay, and then I try to balance my hydrogens by putting a coefficient here or here, I'm going to disturb and change my carbons and my oxygens, and I'll change out. I don't want to do that. By balancing the hydrogens first, I can then come back and balance oxygen right here without changing any of the other coefficients. If that doesn't make any sense, it will once you get more experience doing these. So I have a 6 here, I need a 6 on this side, so therefore I should put a 3 here. I'm not going to write these all out, but that would be 3 water molecules. Each molecule has 2 hydrogens, so that's a total of 6. So now I have to add up my my oxygens. I still have 4 oxygens here, plus I have 3 on this side, so that gives me a total of 7. Okay, so on this side I have to get this oxygen to be a 7. I don't want to put a number here. If I put a number here, I'm going to change carbon and hydrogen, and I'm going to go through this big roundabout, I'll never be able to balance it kind of thing. It's just very frustrating. So I'm going to do is I'm going to put a number here. Now remember that I have to add the 2 oxygens together, don't I? So I have to put a number here that will multiply by 2 and then add to the 1, right? So I want that all to equal 7. So therefore, if I have 1 over here, what do I really want this to equal? I'd like it to equal 6. I hope you kind of saw that. So by putting a 3 here, that's going to give me 6 oxygens plus one more oxygen here makes that 7. So now I have the same number of atoms on both sides of the reaction. My reaction is balanced, and I can then confirm that the law of conservation of mass has been upheld. What that means is if I added up the carbon's mass, hydrogen mass, and oxygen mass, and then I did the same thing on this side, those two masses would be exactly the same. And that's the law of conservation of mass. And that's why we balance, because of that law of conservation of mass. Alright, so I'm going to balance this one. If you want to pause it right now, you're welcome to do that. And by pausing, you can try to figure it out yourself. And then if you can't do it, watch the video and, whatever, you get the idea. Alright, so I'm going to go ahead and potassium, okay, hydrogen, and oxygen. 1 potassium, 2 hydrogens, 1 oxygen. Potassium, I'm going to keep these in order, by the way. Keep them in order so that it's easier to compare. Don't just follow the order up here. Okay, my potassium is 1, my hydrogen is 3, my oxygen is 1. Alright, so if I'm going to go ahead and balance, I'm going to start with, have to put coefficients in here. Alright, so potassium's okay, oxygen's okay, my hydrogen is off. Alright, so I've got to get these hydrogens to balance. Well, I got 3 on this side, and I've got 2 on this side. So if you kind of see the way this is going to work out, I have 2 here and 1 here. If I put a 2 here, wouldn't that make my hydrogen a 2 and a 2 and make it a 4? Right? Okay. Now, as I do that, my potassium then also becomes a 2 and my oxygen becomes a 2. Don't forget to change the other elements in there. Don't just change the one you're focusing on. Now I come back over here. If I put a 2 here, I can then make my hydrogen 4. And then my oxygen becomes 2. And my potassium is still 1. So in order to fix that, I throw a 2 here, my potassium is balanced. And that's pretty much it. Okay, so that's balancing equations. It's just a matter of trial and error. To just, don't get frustrated. Just if you get lost, if you get confused, some of them can be tricky. Just start over and try to approach it differently. Notice in this one I started with hydrogens. Over here I started with carbons. Well, if that didn't work, I would just start with another element. Okay, so keep that in mind when you're balancing. Don't get frustrated. Just do your best. Okay, one last one I'm going to show you, and then I'm going to end the video. This one can get a little complicated because there's some little trick I'll show you when you can balance this one. All right, so nitrogen 1, hydrogen 3, oxygen 2. Nitrogen 1, hydrogen 2, oxygen 2. 2 oxygens here, 2 hydrogens, and nitrogens. Okay, so I'm going to go ahead and I'm going to throw the coefficients in here to balance. Nitrogen's good, oxygen's good, so I have to focus on the hydrogens. All right, so I got 3 here and 2 here. So I'm going to use the least common multiple, put a 3 there, make that a 6. So 3 oxygens and 4. So I got 4 oxygens on this side. I'm going to throw a 2 over here to balance my hydrogens to make that a 6. And that gives me 2 nitrogens. Alright, so now my nitrogens are good. I'm sorry, my hydrogens are good. Now my nitrogens and oxygens are all off. Alright, so I'm going to stay away from oxygen. The reason I stay away from oxygen is that it's all over the place. I'm just going to stay with the nitrogens. And I'm going to throw a 2 in here. So now my nitrogens are balanced. I have 2 oxygens and I have 3. So 2 oxygens over here and 3 here. That's going to give me a total of 5 oxygens. Alright, now here's where things get a little crazy. I don't want to move any of the other coefficients because everything else is balanced. I really want to put something right here to balance the oxygens. But the problem is, whatever this number is, let's say it's x, okay? That number x is going to have to be multiplied by 2, and what do I want it to equal? 5, right? So if I want to solve for x, what does x have to be? 5 halves, right? So what I could do is I can come up here and say, okay, x has to be 5 halves. But the problem with that is that that's not really appropriate because I can't have 5 halves of oxygen. So what I have to do is I have to get rid of that half. This is kind of a little tricky. You can't really keep it this way. So what I'm going to do is I'm going to double everything. So if I double this, this becomes a 4. I double this becomes a 5. If I double this, it becomes a 4. If I double this, it becomes a 6. and now I have everything balanced. 4 nitrogen, 4 nitrogen, 12 hydrogen, 12 hydrogen, 10 oxygen, 4 of them here, and 6 of them here, and I get a balanced equation. If you need to watch that again, go ahead, but and I'll explain this trick again if you in class if you still have questions on it. But it's a little tip, a little way to kind of sidestep and try to alleviate the balancing, is sometimes the halves can be pretty helpful. Alright, so that's balancing equations. We'll try working on these in class, and I'll see you later.